So this is another topic in Unit 8 for logarithms, and it's residuals. So we've talked about residuals in previous units, and we can think of it as error, or a more definitive definition is that it's the difference between the actual value and the predicted value. So we're also going to be looking at a residual plot. So in the previous units, like exponentials, we would talk about one residual at a particular value, or not a value, but like a time. So t equals 5, what's the residual for that when we compare the actual data to the predicted model? So a residual plot shows all the residuals for a set of data and can be used to help determine if a model is appropriate for a given set of data. So the set of data that's given is usually in a table, or you can see it on a plot. And then our model is going to be the line that goes through the residual plot. So what a residual plot will look like is if we have a set of data, and act like none of these are on the same time. So let me try and do a better job of that. So we'll come up, boom, boom, boom. So if we look at this one, try and make it more obvious. So the most appropriate model for this one would be an exponential model. So if we were to pick a regression based on the data that is given, it fits an exponential curve, so we could use that to create a prediction model. Now, what we're doing basically is we are taking the ends of our prediction model and we are stretching it out, right, to become flat. But when we make that adjustment, actually let me make these open, but when we make that adjustment, the actual data or the plot is coming with us. So if I see this dot here, it goes just above it. This dot is a little more above it. This one falls below our prediction model, so I'll put it below. This one's a little bit more below. This one's hugging, more below, closer, and more below. So all of your residual plots will end up looking like this, where we take our prediction model and we stretch it. So the same thing would happen if we were to use a quadratic. So if we had something like this, for our residual plot, the same thing would happen. We would take the ends of our plot and we would stretch it so that it would end up looking like this, which is what we see over here. So no matter what prediction model you use, your residual plot will be a flat line where we have 0, and then we're going to have how much is it off of the data that was provided, okay? So we want our residual plots to not have a pattern, because if it does have a pattern, like if we were to use a linear prediction model for this one, and then we took the ends and we flattened it out, we would see that our data would have a dip below it, which would be these points here. So we can see that there is a curve with these points, which is why exponential is probably the most appropriate. But if we were to do a residual plot based on a linear model, we would see this dip here. So we would see a pattern. So that's bad. If we see a pattern in our residual plot, that means we chose the wrong model, okay? So we don't want to see a pattern because that means we chose the model that is going through the data that was provided, okay? So number 14 says an exponential regression was used to model a data set. The residual plot for the exponential regression model is shown. Which of the following is the best conclusion about the appropriateness of the exponential regression model based on the corresponding residual plot? So based on what I just discussed, we do not see a pattern here, which means that was the appropriate model to choose because this is the model that goes through the data that was provided the best, all right? So the exponential model is appropriate, which means we can count out A and B. And it's appropriate because the residual shows no pattern or because the residuals show a pattern. It's going to be because it does not show a pattern. If we were to see a pattern in our residual plot, that means there is another model that fits the data more appropriately, okay? So when no pattern is shown, this means there is no other model that would be more appropriate. So do you see a pattern in the residual plot? If the answer is no, the model is the most appropriate. If you do see a pattern in your residual plot, that means there is a more appropriate model out there. So below we have three different regression model residuals. It's the same data, but we're choosing different models in order to see which one will fit the data the best. So we have a linear regression model, a quadratic regression model, and then an exponential regression model. So the question states, a group of AP pre-calculus students used a set of data to create linear, quadratic, and exponential regression models. After creating the three models, the students created a residual plot for each model type. Based on the three residual plots above, which model was the most appropriate for the data? Give a reason for your answer based on the residual plots above. So this just stems from what we discussed above, but now we can actually see, okay, what does it look like when we choose a regression model that does not fit the data the best? So if we look at this linear regression model, the residual plot, we can see that there is a pattern with the data, okay? So this means there is a model that would fit this better than the linear regression model. We can see another pattern with the quadratic. Now, it could be any type of curve, all right? We don't know exactly what model would fit it best, but we know that it's not going to be the quadratic. But now we see the third choice, exponential regression. There is no pattern, and the data is hovering around our exponential regression model, okay? So the residuals are the least, or they are the closest to our model when the regression model is exponential, okay? So this means the exponential model was most appropriate for the data because the residual plot shows no patterns. The residual plot shows no pattern. All right, so for now, this is all we need to know about residual plots, and this is going to lead us into a couple other things such as context and data modeling for logs and simulog plotting. All right, hope this helps.